Good day. Thanks for that lovely introduction. Let's do a little bit more of an introduction. So I'm Bram. I'm currently a cloud engineer at something called Seaplane.io, your friendly AI um, hoster in the cloud. Um, yes, I am both an ambassador and a Nomad core contributor. So am going to talk about why friends don't let friends use Kubernetes. There's other ways, and hopefully at the end of this talk, I'll have convinced you that Nomad is the way to go. Um, and to do that today, we're going to introduce Bill. Bill is probably like most of the people online right now, a fellow engineer that has heart for his company or the product he's building, and he's decided to join the on-call team. But just like me, Bill is also a big fan of sleep. Right? Yes, on-call is necessary. Because we only work 8 hours a day and our product in a modern world is online 24/7. So we'll need to have some form of cover for the other 16 hours. Having said that, Bill likes to sleep when he should sleep. So what we try and build today is a platform that can absorb pretty much any damage or users we can inflict upon it. Um, so as a start, I want to pose the following question that we're going to build up to answering. What would it take to keep the platform running no matter what and not wake up Bill or us while being on call? So when we could wake up Bill, it's for something that is really important, that is not auto-correctable, that really needs human intervention. And otherwise, we'll try and build a system that's going to absorb. Um, So back in the days when you're, gray bearded like me, um, how you would want to well, where you had to scale really was if you wanted more space to have run your program. You basically bought a bigger PC, or as you see on the left, that's a 5 MB hard disk for an IBM system somewhere in the 1960s. You would have to build a building around it. You would need to find money to cool it. It was very slow. So scaling took forever. And during the years, we actually went to horizontal scaling. So we're going to add more nodes um, to stretch our workload. We'll stick a load balancer in front of it, and then we'll make sure um, we distribute our load so we can absorb some form of failure. But still, it needed to order stuff. It needed to be in a server room. We need to cool it. We need electricity. We need interconnectivity, and that's not how we do things in the cloud anymore. In the cloud, what we want to do is we want to absorb that additional pressure and pay for exactly what we need. And that's hard because actually need to be able to predict what's going to happen, or we need to predict um, when people are going to show up, well, when users are going to show up, when traffic is going to show up, when it's going to go away, and how much lead time we need to basically put new hardware in place. And that's one of the reasons why we used to wake up Bill. Right? We predict, well, we're not going to predict because that was before AI predictions and everything. We would have a metric somewhere that said our hard disk is going to run out, our CPU is going to run out in X time, and X time should be slightly longer than it took Bill to spin up a new server. Still, that's not something you want to break Bill up for. That's something a system should be able to just do by itself if we can give it the right signals. Right, so we actually need to aim for this magical 5 nines uptime. Then Bill pretty much only needs to wake up when stuff is really on fire, when data centers are actually on fire. Although at the end of the talk, I'm going to hopefully show that even when we lose an entire data center, our platform just keeps running, albeit in a slightly pretty broken state. But we'll keep going. at least some of it will keep going, and then not it's enough should be keep going for our customers to not really notice what is going on in the background. Right, to that, we're going to introduce Nomad, the HashiCorp uh, task scheduler. Well, the HashiCorp created task scheduler. Compared to other schedulers like Cube, it actually can do more than just Docker. Although the examples we're going to show today is Docker based, but pretty much anything I'm going to explain today, you'll be able to do on containers, on even basic jar files or binaries that you've defined. It can do batch work. It can do long-term, long-running containers. It can do even scheduled work if you ask it for it. For those of us that are more comfortable with Terraform, you're in luck because the configuration files, the job files we're going to write today are also written in the same domain-specific language called HashiCorp Configuration Language, or HCL for short. So let's build our awesome product. Well, on the screen right now is the most basic Nomad job you can think of. It's going to be, as naming things is hard, it's going to be lorem ipsum. You're going to see that come back a couple of times, but it's basically our awesome product yet to be named. You'll need to have, you'll have a job. You stick it in at least one group, and every group will have tasks that will be related to each other. And then you'll need to add at least two other things. You'll need a network definition. Basically, you're going to say my thing inside the container or on the node is going to run on a certain port, and we're going to give it a nice name, and we're going to define it as this particular application is going to run in the container on port 3000. It's going to expose a service called lorem, and the task, this definition, is the driver's Docker, as I said, and we give it an image and we say this image is going to expose a certain port, and we reference it by name. Right. If it runs, now Nomad runs it, but it's pretty lonely on this little machine. Nobody can reach it yet. And today we're going to use a tool called Traffic. I think one of the previous speakers also discussed it in his Hashi talk. And the most basic configuration we need to expose our running Docker instance to the outside world is we're going to say we'll have an entry point. It's going to listen on port 80. Please use TLS when you do it, but to keep the example short, today we're going to run on on no TLS. Please excuse me. Right, so we have something listening on port 80, and it's going to have a provider. In this case, it's something called file, and in a file we'll have a, even though I call it dynamic, it's going to be a very static list of locations where my application is running. Right? It's this dynamic file is gonna say two things. It's gonna tell traffic. It's gonna expose something on HTTP, plus other options as well. We're gonna have a router for the lorem ipsum service, and this service is defined as basically a load balancer, a hard-coded list of behind the load balancer. And not even a hard-coded list, it's one. List is one. And basically, we're going to point it at localhost and then a port called 26,489. And that's it's a port that Nomad dynamically assigned to our job. So we, instead of having to hard code things, needing an SCMDB to work out where our stuff is, or how Nomad should start it, we basically say, Nomad, give us a dynamic port. There's ways of asking Nomad to do static stuff, but you can pack Nomad, Nomad client nodes much more if you just say, give me a dynamic port. It's going to be in a certain range that is defined in your Nomad config. It has a default setting I think it's about 12,000 wide. So we'll have a local port. Right, to help Bill in his first step, so make sure we sleep more, is write your application in such a way that you can basically ask Nomad, just don't run me one instance, run me two, and make sure that we run them never on the same node. So if you lose one node, the other one keeps running, our application keeps running. And if you have even more nodes than just the two, basically Nomad will try and reschedule the failing job or the failing task onto a new node. And within, hopefully in a couple of seconds, if we don't have any resource contention, this second instance will come back up and no need to wake up Bill. Right, it sounds all nice and well, but your scheduler should not just be a very expensive systemd, right? So far, I've actually introduced nothing that you couldn't have done directly on the VM or directly on bare metal. So we'll need to introduce a second component, something called HashiCorp's Consul. And HashiCorp's Consul is a service discovery tool, also does service mesh. So I can actually enable ACLs. We're not going to do that today, but you definitely should. It also has a built-in key value store, which we're going to address a little bit later on. And it has something called watchers, which we'll also circle back to. Right? How do we connect our running? Well, how do we expose our running job that we just created before? How do we notify Consul that it's something that we want to announce into our cluster, into our platform, so that other people can actually work with it? So what we need to do is we extend the Nomad job that we have by adding a service resource. In this case, we actually change the name of the service to www, and we're going to give it some tags. We're going to say the service is going to be exposing the HTTP port that we defined before, and actually we're going to add a check, and that's actually very cool in Consul. It's basically you can define health checks. So what we tell in Consul now, and Nomad is actually going to use these checks as well, saying we'll have a name, needs to be alive. That's what we call it. It's a type of HTTP. So what it's going to look for is the service. If the service is up, it's going to look for an HTTP 200 coming back from this health endpoint. We're going to check it every so often, and in this case, every 10 seconds. We're going to see, are you alive? Are you alive? Are you alive? And we'll have a 2-second timeout on that question. So if the answer comes back not HTTP 200, or it basically fails to resolve, Nomad and Consul are going to mark this service as down, and then it's going to act on it. So in this case, in the case of Nomad, it's going to try and reschedule the task. And in Consul, it's well, we're going to see later. It's Consul also can be used as a DNS service. So Consul will then, if the service starts failing, Consul will stop announcing it as part of the SOV record for this service. Right. Now let's update our traffic config, our web server config. In this case, we still have the same router, but we're going to change the load balancer to actually use the DNS entry for the service. So in this case, instead of localhost, we actually can tell it's the lorem ipsum service or the WW service in Consul, and we still have this dynamic port, which is makes it still not entirely as dynamic as we want it to be. So if Nomad starts rescheduling things, this port is going to change. So we need to find a way for traffic actually to pick this stuff up. So if it gets rescheduled, we still don't wake up Bill. All right, so what we actually do is we take this the traffic config that we created before, and we swap out the provider. In this case, we're going to take a provider that's called Consul catalog. It's going to have a default rule, and what that is defined here is if someone comes to my traffic web server and asks for www.loremipsum.io, we're going to look in Consul for the service www, and we're going to forward this request to the SRV records, well, the answers to the SRV records. And we're going to protect ourselves a little bit. We're going to say exposed by default is false. So we actually need to deliberately ask for to be exposed to the public web. And if you remember before, our little service definition had tags applied. One of them was metrics. The other one was enabled. Traffic.enabled is true. And this way, if you do that, then it's automatically going to be picked up by traffic, and then it's going to be exposed to the world. So there's no operator intervention required to actually start exposing things. So if you have sort of an organizational split in a platform team and feature teams, or an infra team, or an ingress team and feature teams, they can now basically start deploying their own services. Traffic is going to pick it up, and there's no bill is not required in any of this. So you can hopefully you're also monitoring all of this stuff. That's where the other tag came from. In this case, we created a service, it had the tag metrics. So in this case, we can also configure Prometheus to set up to directly ask Consul about its services it knows, and instead of basically DDoSing our Consul service, we say, I only want the servers that are specifically tagged with metrics, the metrics tag. So those are the servers that people actually want to see metrics for, and then we can automatically expose those. There's a similar version to Nomad Service Discovery. That's the one I wrote a while back. But today we're going to use the Consul Service Discovery. Right, so now, what if we have two running instances, they're running on distinct hosts, but what if, let's say, we get /dotted, or we hit some news website, or it just happens to be that we are a 24/7 shop, and Bill is asleep because he works in Europe or the US, and people are shopping on our website in, let's say, Sydney or Brisbane or Auckland, somewhere, in a time zone, in a 12-hour time shifted time zone. So what we can now do is also extend our job, the original job that we created, by adding a scaling block. For that, we also need the Nomad autoscaler. That's been around for a while. That's something you can also run in Nomad itself, luckily. Since 0.4, the autoscaler now is also, you can make it high available. So before it wasn't, so it was always a bit interesting that the thing that makes other services high available itself wasn't high available. But with the introduction of locks in Nomad 1.7, we can now have a high available autoscaler as well. And we can ask the Nomad autoscaler that also listens for events on the Nomad event stream, and it listens for well, it basically looks for jobs that have a scaling resource set, and in this case we set it. We'll start it with false, but eventually we're going to turn it on, and we're going to say we want to have at least instance running everywhere. The maximum of 20. Always set a maximum, otherwise you might basically blow up your entire cluster. And that's the point. If it starts to hit 20 and we still see we're missing service level objectives, so we're seeing a crash in the amount of dollars we're earning per minute, or we see website loads basically get very slow, that's when we still want to wake up Bill. But for most cases, 1 to 20, or find your own numbers. that's going to be fine. And what it does is then we set up a Prometheus query that looks for certain metrics. In this case, we're going to actually have a look at traffic itself. Traffic exposes metrics for every route that we set. So we can actually specifically ask for the lorem ipsum ww route. And then we see, if we see traffic go up, we ask the Nomad autoscaler to basically get a sweet spot of about 5. And that's 5 requests per instance. If we go above, then there's a little grace period of about 30 seconds. If for 30 seconds we see our load on an instance be above 5, then we'll start auto-scaling to the point that we're, on average, on all instances, we're about 5. So we saved Bill a lot of sleep again, except when we're really popular. That's when he needs to be online. Right. We've built a job. We made sure it runs on more than one instance. We made sure that it auto scales when we see pressure. The next step is getting it to places where users are. Right? If you have the example of people shopping in Sydney on a website that is hosted in Europe or even US West Coast, the latency itself is going to be killing for those people. It's going to feel slow. I'm a resident in the EU, so we're covered by the GDPR data protection. So some of the data you actually need to bring very close to me because that's where it's you're legally obliged to host it. So what we actually want to do is not just build the one region, we're going to build multiple regions to be close to our users. That also has a benefit that when one of the regions, we lose an entire region, we can still we can still be up for at least everybody else. And hopefully we can just redirect the traffic to the for the users in that region that is affected to somewhere else in the world. For that, we're going to actually build Nomad Federation. We're going to configure Nomad Federation. So we could build a global cluster, but we're not going to do that today. And why not? Because one, the reasons I mentioned before, it's actually quite hard to separate data. Well, it's not hard, but it's harder than it should be if we just didn't federate. And also, we basically, if you do that, one ginormous global cluster, Bill is going to be very sad because if something happens somewhere in the world, we're going to wake him up. Whereas if we build these things in distinct regions, we keep our failure domain to that one specific region. That's better for Bill or Bill's colleagues that hopefully also work around the world. So the only thing that we really need to do, change our default config, is say, instead of just rejoining our local cluster, also start rejoining with the other clusters that we've set up. So it's actually a very loosely coupled connection these clusters have, and that's what we're looking for to preserve our failure domains. If you are lucky to run on a provider like AWS, Consul and Nomad have some code inside of it that actually allows you to look up which service to join or auto join based on tags in your inventory. Today, I'm not going to show that because those servers are quite expensive, and we're going to actually discuss running things on tier 2, tier 3 providers that not always have these all the things you would expect to show up. Also, what I want to propose you do highly strongly suggest split your workload regions, so the regions, the failure domains that you're exposing to your customers, from a management region. Why? Because if you start turning on ACLs on both Consul and Nomad, you're going to have to do some manual sort of bootstrapping to get that original secret into your system. So that's the management region. That's the one you're going to manually, this is the only one you're going to manually manipulate. And then your workload regions are just n. We're going to add 1. It's n plus 1 instead of, oh wait, we have all workloads. Not all workload regions are created equal. We have this one special one. And so if you can afford it's going to be a little bit of additional overhead, but you don't have to run these servers on massive um, hardware or massive VMs. It's going to have very little workload itself. It's just an organizer. So, and then for that, you need to have something set called the authoritative region. So if you going to have ACLs, you send them into your management region, and it's going to get replicated to all the other workload regions. It's the same for namespaces and node pools, another amazing feature that was introduced into Nomad, where you can have specific workloads run on specific nodes just by asking for a certain node pool. Or if you're into namespaces, you can actually define namespaces to have a default or even a short list of node pools you can be allowed. So you could you run your own services on your own on an internal node pool, whereas all customer workload runs on a customer namespace and node pool. Right, how we're gonna change the ingress, because we have now multiple regions, but we all want to end up on the same www.ipsumlorem.io website. So if you can either go full hog and do BGP everywhere, but who has the time for that? So some DNS providers like NS1, like Route 53, they actually have something called GeoDNS, where you can say, I know the ingress IPs for all my regions, and I'll set up a DNS record that basically points www.loremipsum.io to my US region, to my EU region, and because they know about locality, there we can define region. And this I'm showing US, but you'll have similar ones for any country region. You can put NS1 as an example. You can set the regions fairly fine-grained. So that's how we're gonna make sure that we're gonna expose all the regions on the same DNS, and they actually already have some form of failover. So if one ingress stops, it simply fails over to the next one. Although I haven't shown the health checks here, but you can set those up. If we're circling back to metrics, what you want to do when we're building these regions, we're going to build these regions like they're carbon copies of each other. So if I have a Prometheus service in one, I have a Prometheus service in the next, or I have a lorem ipsum in one, I'll have a lorem ipsum in the next. And when we start monitoring these, it's actually quite hard to work out where the signal is coming from, unless we know the entire DNS plan. So if you extend your Prometheus config by having external labels, life is going to be much easier, where you can actually find and search on these labels. In our case, we always said data center, we also said region, we always said environment. So what would it take for us to keep running while we lose an entire region, right? The Haribo at the end of the rainbow. So not only do we want these entire regions, we actually want more than one region, because someone might dig up a data cable, or they only have one data cable into the data center, hopefully not. So what we can do is actually sort of think of it really as a region, right? We have multiple data centers or availability zones if you're in one of the cool data VM providers, or yeah. So what would it take for us to have a US region? But what happened is we run in multi-clouds, not only for failure, but also to prevent vendor lock-in, right? Some vendors, they bump their prices, or they have a temporary shortage of hardware, right? Where we're an AI company, so we're all fishing for GPUs. GPUs are really hard to find. So it might be that provider X has them right now, and provider Y doesn't. So what we can actually build a region, a Nomad region, build multiple providers. What I do have to have a little caveat. I'm saying if you're not running on the big providers, if you run on multiple providers, right, you're going to have a problem where not all vendors are created equal. So they're not going to provide the same VPC facilities. You might not be able to peer them. Your base images, even though everybody says it's an Ubuntu 2204, they'll have slightly different configuration settings. So that's something you need to create a Venn diagram with the least offensive set of things. You're probably also going to run your own network mesh. In our case, we use something called Nebula because some of our providers don't provide private networks or anything. Basically, all VMs are on an open network directly on the internet. So we need to create our own little layer to separate things. So here's where I'm going to introduce basically some config for Consul to actually help us to redirect things. So that's why we built a service discovery tool. And I'm going to show you some things here in Consul where sometimes I'm going to call something a DC, but it's actually the equivalent to a Nomad region. Right? Although both products are created by HashiCorp, they don't actually use the same words to mean the same thing. So when I say a Nomad region, I mean a Consul DC. And when I say Nomad region, there isn't actually no equivalent in Consul. So you're going to see some Consul DCs in a minute that going to arrange traffic for Nomad regions. So in this case, we're going to update our traffic config a little bit for to actually use the Consul KV store. And why am I doing this is, so let's say we open a new region. That region is not going to be populated right away. So we're going to end up with an empty region that we actually are adding to DNS. So local people in this new region are actually going to show up to this empty data center. So what we need to do is we need to be able to redirect from the new data center to the one of the old ones that is fully up and running. So we're going to actually use Consul service catalog is going to be empty because it's also per failure domain, so per Consul DC. So it's going to be absolutely empty. So what we need to do is we'll add the Consul KV store where we're going to have endpoints. Don't forget to add the S. That's always gets me the first couple of rounds, and it's still going to point it at Consul. And then what we can do is actually write a Consul KV value into Consul, and then we can have traffic actually routed based on what we send in. So what we do here is, if someone shows up in EU, but EU is not open yet, we're just going to directly point it to our USA endpoint. The other way, what we could do is something called Consul queries. It's a way where you can actually set failovers already for services. So in this case, we're going to set for the service www, we're going to set if your local DC fails, go to US, then go to EU. Or if we're really lazy, well, not lazy, well, we're a bit lazy, but we want to stay asleep for more, and we don't want to be woken up by people having low latencies, we can actually ask Consul to look for the nearest Consul DC to forward traffic to. And that will keep Bill asleep still, because people are happy, we route them, and actually we can update the URL that we just used. Instead of using the public DNS entry, we can actually we can redirect the traffic internally, which might be cheaper and better. Right. And discussing this local the nearest might not be the best way. So a hard-coded list might not be the best way to go forward because things might change and one of the other regions might be down. And nearest might actually cause traffic a cascading problem in your regions, right? So if one fails over and the nearest one is by definition it's nearest, so it might be in the same time zone, people might be shopping there already. So if we actually move the load to this new data, to this new region, we might actually the system might be so popular that we actually crash this next region and then the next region and the next region. So should we follow the sun or should we follow the moon? Basically, well, instead of failing over to the nearest one, we actually fail over to the one where we know there shouldn't be any traffic due to the local users being asleep. So Consul has a system called Consul Watchers. What you can do is you can ask for basically watch the list of services in your local service, in your local DC. It pulls it, and if it sees a change, you get an answer. Well, you can basically push an answer with this is the current list of services. You'll have to have a somewhat of a state store. So, and then you can compare. Okay, this is a service that just went away, and you can write a little program, shell script, Go code, Python code, Ruby, whatever you're comfortable with, that takes this list and compares it to your state store and then goes, okay, based on a configuration file that I have, a configuration setting that I have for this particular service, I want to follow the sun or I want to follow the moon, or I want to try and triangulate this new nearest and then update my little list of my failover config. And in that case, I think I've proven that we build a system that can pretty much survive any damage or traffic or popularity that we throw at it. And we haven't woken up Bill yet. We've woken up Bill once when it really was popular, when the autoscaler didn't even manage to absorb the traffic. But that's the only reason, when we're that popular, that we're that's the only reason now we're going to wake up Bill, and that's a valid reason to wake up Bill. Everything else, basically, the system was managed to absorb. So thank you for listening. If you want to chat at me, I'll be around in the various chat systems for a while. If you want to look at this slide some more, I'm going to be on the forum and it's going to be on the SlideShare. Thank you very much.